handwriting recognition app. In this set of videos, we will develop a model capable of recognizing handwritten characters and we will deploy it in an Android app. In this video, I will present the general steps that have to be done to create this sort of application, our approach, and I will also show the dataset. At first, we have to present a picture. In the case of an app, we will take the picture using the smartphone's camera. Then we have to detect where is the text. After that, we have to split the text into characters. And finally, once the characters are individually separated, we perform the recognition. These three last steps are very different problems, and tackling each of them is very difficult and complex. For text detection, we can take advantage of the environment's knowledge. For instance, if we want to recognize the characters in a license plate, depending on the position of the camera, they might be always located in the same area approximately. There is a lot of research about text detection. Splitting the text is another problem that can be approached in many ways, like taking into account the height and width of the text to guess the dimensions of each character and separate them by the white space next to them. We won't do any of this task in order to focus on creating the model for the recognition part. I will talk about the dataset later, but our input will consist of a vector of size 784 that will be transformed into a matrix of 28 by 28, the size of the picture. We will perform a first convolution with 32 filters of size 3 by 3, and this will produce 32 26 by 26 matrices. We will perform another convolution with the same filter size, and this time we will have 64 24 by 24 matrices. We will do max pooling, so the dimensions of the matrices will be half, and we will transform this into a vector. We multiply by the corresponding weights and we will get a vector of size 128 and finally obtain a vector of size 47 because we will have 47 different classes. We will use rel activation everywhere except for the output layer where softmax will be used to obtain the probabilities. We will see the other details of the networks directly in the code. Now I will present the dataset. In most of the tutorials you can see that people use MINST, a very well-known dataset of handwritten digits. But I thought it's boring to use always the same dataset, so I'm gonna use a new extended version of MINST that consists of digits and letters, both uppercase and lowercase. There will be 47 classes because some of the lowercase letters have very similar shape to their uppercase versions, for example C, O, P, U, etc. Then each image in the dataset is represented in the form of a vector, and that's why if we want to use convolutions we have to transform it into a 28 by 28 matrix, but we have to be aware of something, and that's why it's very important to visualize the dataset first. When we transform the image of a character, let's say K, we will have something like this, and as we can see, the letter K is oriented in a different way. Noticing this is very important because if we train our model this way, we also have to rotate the image we will feed into the network in the mobile app. The reason why this happens is just because the axes of the matrix are swapped. Finally, the dataset will consist of 240,000 training and 40,000 testing samples. The labels provided are numbers between 0 and 46, corresponding to the class they belong to. And at first, we have to transform it into a one-hot vector, which means a vector of zeros with a 1 in the corresponding position according to the label. We also have to have a look at the training data and the data we will provide to the model. If we compare our input from the pictures taken in the smartphone and the training data, we can see that the colors are different. In case of the training images, the background will always be 0, and the letter will be represented by non-zero values, while the provided image background will be light gray and foreground dark gray. In order to solve this, we will threshold the data so that we have black and white images. We will also normalize the images to have values between 0 and 1, and as a result, 0 will represent the background and 1 will represent the letter. And we are good to go now. In the next video, we will start implementing the model.